Welcome, everybody. I'm glad to be here. Thanks for having me. My name is Filip. This is my lovely family and my Twitter handle. I work at a company called Impact. I'm from Denmark. We have offices in Aarhus and Copenhagen. We do e-commerce for lots of cool companies that you might have heard of. About 2.5 years ago, I joined Google's Developer Experts program. So I get to sit down every once a month with the guys from the Chrome team and the Angular team and the Polymer team, and listen to and talk to them about where we're going with the platform and the frameworks, and where we think like the ecosystem and the community is going. So that's pretty exciting. But enough about me. The title of this talk is something around client-side templating, the future of templating. What's next in client-side templating is the current title I'm fiddling around with, but we know we can change that in a way as we go. But I want to take an approach where I want to take a deep dive into some details in technology, in library and stuff. And the point is not the technology itself. The point is kind of to gain the perspective of the bigger picture of where I think we're going, or where we could be going. So how many of you write JavaScript or web kind of code most days? Most people. If you didn't raise your hands, that's okay. There's going to be a lot of slides with code on them. You can just nod off when there's code on the screen, that's fine. Then you can wake back up afterwards, and I'll try to kind of lift it up again and take the grand perspective again. But it's about templating. And templating is kind of a way to build the user interface. So for the web, it's something like HTML, and we want to build it in a declarative way, or in some kind of format that looks like the HTML that we want it to be eventually. There's some parts that are static. Typically like there's going to be a header tag, and the H1 itself is not really is not going to change, but maybe the text content inside of it is going to change. So some parts are static, and some parts are dynamic. And like, there's happened a lot in this area or in the last couple of years. But if there's one thing that React has really taught the world, is that we can think of our UI as kind of a function of the state. So whatever we have a state, a new state, whenever state changes, we pass that to some kind of function, and that function will return some view for us. So that's kind of how we can think about templating today. And that's what this talk is going to be about, how this could look in the future. So in order to talk about the future, a good way to start is always to talk about the past. So I'm going to start with the trip down memory lane. So if you've been doing web for a long time, like I have, you might see some stuff that you remember from back in the days, and you might see, oh, that was the good days, or you might be one of those, I can't believe we actually did that, and it's probably a combination of the two, for me at least. So the early days of templating, it was something like this. So we basically had a value here, it's called where, and then we just used string interpolation to put the value inside of another string that contained, so now we have the data in here, and then we could just put it on the body element or on any element within HTML, and we were good to go. So this was like templating 101, or maybe before that, like that was very, very early stuff. And then like the next iteration was something where we started to create the elements imperatively from JavaScript, so that we then had like references to them. So then we would set the inner HTML on the title element. And the cool part about this is that then when we needed to update it, we already had the reference to the element, so we could just update that part and not re-render the entire DOM. So that was kind of cool. So the next iteration was something like, that kind of started looking like a templating language that we would know today. Mustache was, I think, the first front-end templating language. The name is Mustache because of the curly brackets. They kind of look like a mustache. And the cool thing is, they gave us a way to write templating in a way that felt like we were writing HTML, and we could like mark that this is the dynamic parts of our code, and then they would give us a render function you see here, where we could pass in a state object, and then that state would then be merged into the template, and we were good to go. So under the hood, what the mustache.render function does is a pretty complex regular expression that kind of figures out where are all the curly brackets, and then it sees what's inside the curly brackets, and then it matches it up against the state object, and we're good to go. The problem is that then, whenever we change this, we need to call mustache.render again. It needs to do all of its regular expression stuff again. It needs to match all the values again, and then we have the value again, and we replace everything. So it was a good thing for developers because we kind of got a syntax that we liked. But for users, it was kind of terrible because it was slow and it was, not very nice to look at. The next iteration of this was handlebars, and this was where most of us probably started, or a lot of us probably started. With handlebars, we had a syntax that, again, looked like mustache with the curly brackets, but now we had some kind of control flow statements where we could do if and else, and we can do loops and all that kind of stuff inside of our templates, so we could actually make smarter templates. So handlebars gave us a lot more for the developers, but they also took the stupid thing out of doing the regular expressions every time we had the data change. So what the compile function actually does here in line 8 is it hands us back like a templating function, and then we can call the templating function over and over again with the new state, and then we only update the DOM based on that. So that was actually kind of smart. Handlebars is still what frameworks like Ember still uses today. Or I think the new iteration might be changing, but up until very recently, handlebars was still actively used. And if you look at the templating syntax, is not very different from what we see today. If you look at Angular, if you look at JSX or stuff, it's kind of familiar. So again, as I said, then when we needed to change the state, we would just call the templating function over again, and it would work out. So pretty cool. So then, 5 years ago or something like that, JSX happens. So if this is the first time you see it, you probably have it feel like the same as I did when the first time I saw it. Like I puked into my mouth a little bit, because the first time you see it, most of us we feel like this is wrong. Like, why would we put tag names inside of JavaScript like that? It just feels wrong. And of course, it is wrong. Like, it's not valid JavaScript, but it's not. That's not really the point here. So what JSX does is it's actually it compiles down to some function calls that actually does a lot of smart stuff. But from a templating perspective, it gives us some cool stuff, because the stuff inside of the curly brackets here, the where, is actually a real JavaScript expression. So we could do ternary statements, so we can do array loops and all that kind of stuff inside of our template, and it's very useful for that. So if you don't know JSX, as we saw, like the UI is a function of the state. So here we have the greeter, which is the UI, which is a function that takes the where state and puts it inside here, and it just returns immediately the h1 tag with the where inside of it. And we use the single brackets here, except like if it was handlebars, it would have been double curly brackets, but it's just a syntax thing. It's pretty similar in the way you use it. But the way, or the place that the JSX really, changed the way we thought about templating was when it comes to like doing imperative stuff. Because we can do ternaries inline, we can also do like arrays inline. So these are the name of my kids. I thought I would make a kid list here. So I have just a UL tag inside of my template, and then I just map over an array of my kids. And for each of them, I return some LIs with the names in it. So it's pretty straightforward. This is a way to render a list, and it's like the user experience or the developer experience is pretty nice when you get over the fact that you put templates inside of your JavaScript tag. So yeah, and then we see like in line 9, we call the render function, which takes care of actually turning this into DOM nodes and keeping them up to date. So whenever you call it the next time, we can officially only update the part that has changed. So this was the history of templating. I hope you've caught up, and we're all at the same time or the same place now. So this begs the question, what's next? And to answer that question, let's take a step back and say, what is the job of the templating system? It's really to keep a balance between a very good developer experience. We want something that's nice, that works with our tools, and that's feels familiar to us. But we also want something that's really fast to do the initial setup and fast to update. So every time there's a change, we want it to be fast. And being a web developer, I like to see what does the platform have, or what does the standards. What do we already have that could be building blocks for something like this? And with ES6 or ES 2015 or what religion you're part of, we had two new or features or whatever you want to call them that has template in the name. So I thought I'll take a look at those. So those are the template element, which is the DOM element. I'll come back to them in a little bit, and then the template literal. So the template element is like a regular DOM element, so like a div or a span or anything. But whatever you put inside of it is like in a deactivated state. So it's called inert. But that just means that scripts don't run. If you put a script tag inside of a template tag, it doesn't run. If you put a style tag, the styles don't apply anywhere. And then the template element itself has one extra feature over all the other elements. And that is that it has a property that's called content, which is made for just getting the contents of the node and not all of the node itself. And that's really meant for cloning. So that every time I need to actually render some DOM, I can take a template element and very easily clone it, and it performs very well. So using it looks like something like this. So I'm querying the DOM to find my template element. Then I'm calling the content, looking up in the content property, and then I'm calling clone node on that with the true option so that it's deep. And then I'm just appending the clone to my DOM, and boom, as soon as I do that, then the scripts apply and the styles run and the images will download and all that stuff. So it's very easy to work with, and it performs really well. So this is one of the fastest ways you can create DOM structures. So the other part is template literals. So a lot of us, template literals are kind of a string that instead of single brackets or double. Thanks. So instead of starting them with quotes, with single quotes or double quotes, we start them with backticks. So the backtick is a little character that kind of looks like it's tilted a little bit. You make it like if you make your hand look like a horse, and then you press it down. That's how you make the backtick. Once you make it once, you just copy it all over, and you're good to go. No, you should learn how to do it. But it's typically hidden really well. But it's a nice feature. It can span multiple lines, so no longer do we have to have strings like where we use concatenation to kind of have strings after each other in multiple lines to make it look and feel like multiple lines. We can actually have strings that span multiple lines. They can embed expressions just like we saw in JSX. And this is more or less what I thought template literals was about. So very simple. A lot of us, or in the beginning, I just thought, yeah, we can do multi-line strings. That's all I wanted to. But you can put in expressions inside there. That's pretty cool as well. But the real cool feature, or the power here, is really that they can be tagged. I'll come back to that in just a second. So this is how it looks. So if you see, it's very familiar to the JSX stuff. So we actually, but now because of the backticks, it's actually inside of a template literal. So it's not gross and not really standard stuff. This is real JavaScript. We have a string inside of our template, and we render that to the DOM. And you see here that we put, instead of just the curly brackets, we do $ curly brackets to start it, and then the curly bracket end to end the expression, and that's how you use it. Other than that, it's just like JSX. It's very simple. The context of this is just where you think it's going to be. So if you use this dot something in here, it's where the string is actually, or the string literal is actually used. So it's very simple to deal with. But the cool thing is, as I said, is that they can be tagged. So a tag is a special function, or not a special function, just a regular JavaScript function that processes the template literal. It processes the literal parts and the expressive parts, so the static parts and the dynamic parts. Both of them, but individually. And it doesn't really have to return a string, so it can return anything. So just to show you how it looks, this is a screencast or a screenshot from Chrome. So you see I make a myTag function here. It's just a regular function. Here it's a fat arrow function, but it's just a regular function. And the first argument that is passed to it when you call it is the static parts in an array. So all the static parts of your template is going to be chunked up and put in an array with all of them in it. And then the second parts are all the extra arguments to this function are all the expressive parts in your template. So here you see I have hello environment, and then it returns the first array is hello, or is the h1 hello, and then the next part is the h1 ending. And then over here is kind of the array of the holes, so world should go in between there. So merging this together to be the final string would be a little bit of zipping this up together, but pretty simple to understand. But it has one extra feature. And the extra feature is that the literal parts array will always be the same when you pass in the same template literal. And that's a really cool feature. So just to understand, so here the tag name is the same. I didn't know if I said it, but putting the tag in front of the template literal is just how you tag it. So you put the function name, and then you just right after that you put the backticks and your template literal, and that's how you tag a template literal. But here you see that the static parts. So this is a tag that just returns the static parts. So just the array, and here I'm just calling it twice with the same template literal, and seeing that it's actually the same identity of the object or the array that's being returned. So that's a pretty cool feature, and I'll come back to why in just a second. So I thought to myself, maybe we can use these two features to create a cool templating system that's very close and very native-like, and so we can make it very small and very efficient and all that cool stuff. So again, let's start here. So we want to have something that's good for the developer and good for the user. So we want it to be fast, both to update and to boot. So a solution could be something like, if we use template literals for our templates, it's actually valid JavaScript. So we don't need to tell our VS Code or whatever editor you're using, WebStorm or whatever, that this is JSX and install plugins for it not to throw up over invalid JavaScript in our templates or in our JavaScript files, because this is real JavaScript. So we have the huge set of templates or of editor plugins that help us figure out what kind of stuff is in here, that helps us debug our templates and all that stuff. That all works out of the box because this is standard JavaScript. So then whenever we have a template, we could use the template element to kind of create an instance that we can very easily clone. So it's really fast to create the DOM eventually. And then because we know, we can do the setup only once and use the fact that the static parts array are the same, they're the same identity, we can use that as a caching key. So we don't need to pass the templating function around to have the caching. We can have the framework handle the caching automatically, because once it sees the same thing, it's just the same template. And we know exactly what has changed. So we can be very efficient about only updating what could change with what has actually changed. So this is pretty cool. Of course, this is not entirely my idea, or I'm not the first to think of this. There's already a couple of frameworks out there. There's one called HyperHTML. There's LitHTML. There's a framework called Inner Self. Or they're not really frameworks. They're more like libraries or micro libraries even, because they're really small and they just do one thing really well. So let's raise up again and see. So this is actually pretty interesting, because we can use the native stuff that the browser gives us to make something that works really well for the developer, but also for the end user, because we can utilize the fact that the browser has implemented these features and they iterate over them and they make them faster. So every time the browser makes it itself faster, our stuff is faster. We don't have to have any framework that updates to be faster. When the browser is faster, we're faster. So I want to talk about LitHTML. So I could have just as easily chosen to show you HyperHTML or Inner Self or one of the other ones, because the point I'm trying to make is not you should use LitHTML. It is to check how cool our platform is. We can do awesome stuff, and people are doing it already, and we can actually start using some of this. But I'm going to show you LitHTML just because that's probably the biggest one, the one that has the most traction. So LitHTML, it's by some of the people from the Polymer team. It's mainly by a guy called Justin who works at Google. And it's very simple. It's a tag function. It's called HTML. So it's an HTML tag that returns something that they call a template result, which is more or less like you can think of it as like a set of instructions that you pass to the framework or to the library, and then the library knows how to make those instructions into real DOM. So it's like an object, but it's like a set of instructions. You can think about it that way. And then it has a render method, and the render method is, what I just said. The render method takes the template result and turns that into DOM and does it in the most efficient way you can think of. And then it's tiny and super fast. So lit.html itself, gzipped is around 2 kilobytes of code. So we've just seen like frameworks like React and Vue, and they're all like fighting to keep themselves under 100 kilobytes of code, and this is 2 kilobytes of code. So it's very small and it's very efficient. So it's very fast to ship even to small devices with poor internet connections. So using it looks like this. So if you remember the JSX example, this is the exact same thing. The only difference is that the binding has the dollar sign in front of it. Other than that, the template is exactly the same. And then you see like the HTML the HTML tag in front of the template literal is what actually makes it work. And then you pass the result into the render function, and you give it the document body or wherever you want it to mount, and then your template is rendered. So this is using lit.html right out of the box. It's super fast. It's super easy. So what can lit really do for us? So as we saw, we can handle text content. That should be a no-brainer. Anybody should be able to put a header or whatever into the DOM, and that should work. We can do expressions because it's real JavaScript in here, so we can do, indexes are typically, from a computer perspective, starting with 0, and from the human perspective, it's typically sized by 1. So maybe you want to add 1 to all your indexes. You can do that right in the template if you want to. We can do expressions like show this or that, depending on some kind of, because we can do ternaries. Then we can do attribute bindings. So in here, it's just a div tag. And we can bind directly to the ID attribute like this. So it's pretty self-explanatory. And then there's a special syntax if you want to bind to a Boolean attribute. So if you put the question mark in front of the attribute name, and that means that if the expression is truthy, then the attribute is going to be there. And if it's not going to be there at all. So it's not going to be there with an empty value or something. It's just going to be out. And then we can handle properties. We put a dot in front of it to say that this is, because that's how you use properties in JavaScript normally. So we put a dot in front of it, and that means this is a property. So instead of binding to the attribute, because attributes can only do strings, with binding to properties, we don't have to have any string, making stuff JSON and out and all that stuff again. So we can just bind directly to the property and have the elements like objects and arrays. We can just pass them down to children like we would expect. We can do declarative event listeners. So if we put an @ sign in front of a name, it turns into an event listener. So this is an event listener that listens for click. And then it fires the alert function here. Here it's an inline function, but this could probably be a function that lived somewhere else. So this fires the alert whenever you click the button. And then it can handle template results. So if we want to do composition, we can have the header in one file and have the footer in another file, and we can import those, and we can put template results inside of our template result, or inside of our template literal. Then we can handle arrays. Arrays in themselves doesn't really make sense, but when you combine them with the composition story, we have something that looks again just like the JSX example, where we map over the list of kids, and the only difference here again is the dollar sign in front of the expressions. So pretty simple stuff. We can handle DOM nodes, so if you want to create them imperatively, or if you have like a jQuery library that you really, really want to use, or an Angular app, or a React app, or a Vue app, you can actually take one of those and put it right inside of your lit.html template, and it's going to work out of the box, no magic, because it's just DOM nodes. It does asynchronous stuff, so we can listen for a promise to resolve, and whenever this promise resolves, it's going to get the eventual value. And being a developer, the next question you ask, of course, is how do we extend this? Like, how do we work with it? How do we make it do more stuff for us? And the answer to that is directives. They call it directives. It's not really like if you've ever written Angular or AngularJS, they have a feature called directives. It's not the same thing. It's just the same word, so forget about that. But we saw this before with the promise, where we could wait for a promise. typically we would really want like an until directive that would say, so here's the placeholder, and then whenever the promise fulfills, then we should have a value. So it should say loading until the content is there or something. And this is how you use a directive, and implementing a directive is super easy. So this is the until directive. It takes the promise and the placeholder, and then it returns the directive for us. The directive only has one API. The directive is called with the part, and which is the hole in the template, and the part just has one API, which is set value. So here I'm just setting it to the placeholder. That activates the DOM, and then I'm setting it to the promise right after that, because then we know that whenever the promise fulfills, it's going to do its thing and put it in. So pretty cool stuff. So this is very powerful. This is a very simple example, I know, but you can extend this in pretty powerful ways if you want to. So talking about performance is always important, and when it comes to performance, we can probably, most of us would be able to come up with a graph that shows the story that we wanted to make. Like if I wanted to say that Angular is faster than React, I can measure something that, kind of makes that look cool. And if I wanted to say the other way around, I could do the test a little bit differently, and that would make the other thing look faster. So I don't want to share graphs. Like you can Google it and you can find graphs that if you want to see it. But I want to talk about, again, from the higher order, like why is it fast, or how does it work? So when it comes to rendering and updating, there's typically two approaches. One, I've come up with these names: unoptimized intelligence, I've called it, which is kind of like what Polymer does. With Polymer 2, we're very clever about where exactly our changes is, and that means that, but we're pretty slow at that. So that means that whenever an update happens, we're very efficient at just updating the parts, but we're pretty, not very clever at finding out which part has actually changed. So that means this scales with the complexity of our change. So if we have a very complex change, it's going to be kind of slow. The other way to go is the React way, or the virtual DOM way, where the name I've come up with is optimized brute force. So what React really does, or what the virtual DOM does, is it makes a representation of everything, then it makes the same representation with the new stuff, and then it just compares them very, very fast, but sees where are the changes, and then it updates those changes. So instead of doing it on the DOM, it does it on the virtual DOM, because the DOM is kind of slow to read and write from, but you can do that very efficiently in the virtual DOM, and then you can just update the DOM just where the changes are. But it is still kind of brute force, and that means like the virtual DOM scales with the number of DOM nodes. So like if you have a huge template, but only have one hole in it, like only one dynamic part, it's going to recheck your 1 million divs every time, even though there's no way they could ever change, because that's just how the virtual DOM works. So what lit does is kind of takes a little bit of the best of both worlds. So because we know just the parts that are static, we know they can never change, and then we have the dynamic parts, and we know these are the ones that can change. That means we can be pretty smart about what places to look for changes and what DOM nodes to keep in sync. And then because we actually get past all the arguments with the values in them, we can pretty easily check what are the values compared to the old ones. Then we do a little bit familiar to how the React story works, but we only diff the dynamic parts. And then when we find the DOM, the changes, we update the DOM accordingly. So it tries to sit a little bit, not in between, but it tries to take the best from both worlds, and that's how it gets its speed. And like if you try it out, you should try it out. It is really fast. But the one thing that it's not very good at out of the box is when you have the huge list, and you just change one thing, because it doesn't hold, like it doesn't work very well. Like if you reorder them, or if you do something like that, it's going to see a change and it's going to do a lot of stuff again. So for that, lit HTML actually ships with the repeat directive. So you use it like you used the directive you saw before, or you use it like this. Like here, instead of just taking the list and mapping over them, I call the repeat directive here with the list, and then saying, so you should recognize them by the ID of the person or whatever. And that way, this actually uses the VDOM implementation from Vue, so which is very small and very efficient. So if you have like big lists, it will cost you a little bit more on the library size. That's why it's not built in. Like you have to import it and use it, so we can tree shake it away if you don't use it. But this way we actually also get really fast updates with lists, so when you're reordering lists. So that's all good. I'm sure you're asking yourself, so show me how to make a component with this. And the answer to that is, lit only handles your templating. You might say, it's bring your own component. So if you want to have some kind of encapsulation, if you want to have some kind of data flow with properties going down and events going up and all that cool stuff like we do with Angular, React, or Vue, or any of the frameworks, you have to bring it to you. You have to bring your own. But again, I tend to look at the platform, and if you've been following along at all in the last couple of years, you know that the answer to this is web components. So web components is a spec that has custom elements, so the ability to make your own elements and kind of know when they're put in the DOM and taken out and when attributes are changed. It's a spec about shadow DOM, so about styles not leaking out and about code not being able to reach in and out of the shadow DOM. Then it's the template element, we talked about that already. And the fourth spec is HTML imports, and that's been deprecated, so you can forget about that. But using web components looks something like this. So it's just a regular JavaScript class that extends the HTML element. So that way you get all of the built-in stuff for free. So you extend that, and then you have some callbacks here. You see there's a connected callback, which is whenever it's put in the DOM. So the constructor is when it's created. So if you create it imperatively, that's when the constructor is called. The connected callback is when it's put in the DOM, and here you see that when I put it in the DOM, that's where I attach a shadow root so that anything inside of here won't leak out. So if you put a style tag in it, its styles will only apply inside of our components. And then there's a callback whenever it's taken out of the DOM and whenever attributes has changed and all that stuff. And then in line 11, you see that I just call custom elements that define with it, with the tag name, and then the class. And that's how you make a custom element in JavaScript today. It's pretty simple. So lit is built for this. So it's a very great fit with web components. So if we want to have an experience that kind of feels like React, we would make a render method on our web component that would return a template result, so return the tag template role. We would use property setters, so whenever a property change, we would automatically re-render the view so that we would have a really nice developer experience, so whenever anything changed, it would automatically update for us. And re-render whenever stuff was invalidated, and we should probably batch that as well, so it's a little bit faster. And then we can just use, dispatch regular native DOM events because they bubble and they're cool, and you can catch them with the regular DOM event listener like I showed you before with the @ sign in front of it. Yeah, so we can do data flow with properties and properties going down and events going up. All of that is pretty standard, and building a web component like that is really easy. But of course, there's already helpers out there for you. Again, I'm going to show you the lit element one, but that's not the point of the story. The point of the story is it's very close to the platform. We can do stuff like this already, and it's really, really easy. It's really, really efficient to do, and it's really, really fast. And this is actually what powers the next generation of Polymer, which is Polymer 3. And yeah, I'm not going to talk too much about that. So lit element gives us especially typed properties. So we can kind of say this is a property that has some extra features. So we can have properties that doesn't invalidate our state, and then we can have special properties that invalidates our state whenever they're changed. It gives us attribute reflection. So if we want to have a property that's also an attribute or the other way around, it does that out of the box. And then it does automatic batching of the rendering. So if we change two properties, it's not going to render twice. It's just going to re-render once. Yeah, it's written for TypeScript. It's written in TypeScript, so the definitions are really good. If you like TypeScript, you're my friend. If you don't, that's okay. You can always be a better man or woman. But using it looks something like this. So if you're not used to TypeScript, there might be some stuff in here that's not that you're not used to, but you can just skip over that. You can use it without TypeScript as well. The decorator stuff is a little bit different though. So you see, here in line 3 and 4, I use the @ sign with the function, and then I call it, and that's something it's actually a JavaScript feature, but it's not really landed in very many browsers yet. So TypeScript takes care of compiling that for you. But it's a way of decorating the next thing in your template, and the next thing is then here you see it's the product. So this is the property or the property on the class. And instead of extending the HTML element class, we extend the lit element class. So this in turn extends the HTML stuff, but it just does all the magic for you. And then we have a render function. And the render function, you see here, I'm just rendering out a product, because we do e-commerce, so that's a good example, I thought. So we're rendering out a product here with a product title and a product description. And whenever we fire the onClick callback, it calls the onClick callback method on my class, which in turns, dispatches a native DOM event, so a parent somewhere could listen for the special event called buy, so we could do @buy on any parent element, and that would catch the event and react to that. So it feels very, very familiar to how you would do it in Angular, how you would do it in React, but this is the native way of doing it. So I was hoping to code a little bit of this, but I'm almost out of time. So we can see, if you have no questions, we'll come back and I'll try to code a little bit of it, but we'll see how it goes. But a good place to start if you want to play with the TypeScript version. My colleague Nikolai made like a starter pack or whatever you want to do. If you like the CLI, you can use the Polymer CLI. But if you just want to play with it, I put a playground up on StackBlitz, which uses TypeScript as well. So if you just want to play with it, this is a very good place to start. Okay, so lit HTML is really sweet to use. Like, it's really efficient at the templating stuff, and then lit element gives you a lot of extra powers. Like, now you actually have something that's comparable to an entire framework or an entire library, but it's still like 4 kilobytes of code. So it's very, very small. It's very efficient. It doesn't use very much memory, and it's just a lot of joy to work with. Already, because it's a Google thing, they already implemented a lot of the material design stuff. So if you want to have components like this, if you're prototyping, these are all built with lit HTML or with lit element. And they can actually be server-side rendered now. For a long time, this was kind of a problem, but the Rendertron runtime, or the Node engine that renders your front-end application on the server and gives you back the HTML, Rendertron now supports web components. So if you want to do server-side rendering for search engine optimizations or for social previewing or whatever, you can do that. If you just type any URL into the Rendertron app, this is just an example app, you can type anything in there and you can see what it returns, and you can see that it works really well with your server-side rendered stuff. So one more thing, this is just me plugging one of my own projects. So the missing part here, I thought to myself, was a router. So I built an element router, and in the spirit of trying to keep everything small, I gave myself the challenge: you should build a router that does lazy loading and that does all the cool stuff that you want it to do, but it has to be in less than 1 kilobyte of code. So I actually built a router here. It's built with native web components, so there's actually no dependencies to lit. You can use it without lit if you want to. So it's 1 kilobyte in itself. It has a syntax that's very close to the preact router, because I think that's kind of nice. It's very declarative, and you do it like the declarations in your template. It's less than 1 kilobyte of code. And it works with anything. So you use it just like custom elements. So you just have the element router tag, and inside of that you just put numerous element route tags, where you define the path, which is what route to react to, and then the element to show. And if you check the fourth line, you see that we can actually, if it has the import attribute, we start by importing that, and then we load the component after that. So it's a pretty cool thing. You should probably not use that for production yet, maybe never. But it's a pretty cool thing I've built. So the closing thoughts is, again, I think this is really cool. I think this is really promising. Lit element might go away. It still doesn't have very much traction. It is a Google project, so maybe it will catch on. But there's probably going to be a lot of other frameworks that do the same thing. So my dream is really that all the frameworks, they should compete on the user experience. Today they're competing on creating the fastest list over and over again 10,000 times, and they're competing on implementing the same stuff over and over again in all the frameworks. So they all have some kind of way to make DOM, and there's some kind of tree shaking stuff, and some kind of way to do the DOM checking if stuff is up to date. And I think we should let the platform do that. So that the frameworks can be very tiny, and the frameworks can focus on giving you the best developer experience. They should focus on you as the developer, because the end user doesn't know what framework is using. So he doesn't care. Like, he just wants an app that's fast, and you as the developer, you want something that's good for you. So I think this is where we're going to go. If you want to, you should play a lot. You should go ahead and play with Lit. I just used it, or we just used it at Impact in the first real project where we put it in production and stuff. And so far it hasn't crashed for us. But I'm not going to say that it's all there and you should all go home and use it. But you should absolutely go home and play with it. Like, this might be the future. It might look a little bit different, but I think these are the building blocks that's going to be the future of our frameworks. So with that, we might have a couple of minutes for questions or not. If nothing else, then thanks for having me.